Okay, so the way that this one reads is y is 2x, okay? It's equal to that, but we just say is. So if y is this, then that means where the y is at in the other equation, I can replace it with that because what that is what y is, okay? So I'm taking this and I'm going to replace it with the y. So I'm going to rewrite this equation. So now I don't have two different variables. I'm only going to have one because I'm replacing the y with something else. Okay? So if I put this there, I now have 2x in the place of the y. The y is gone because I replaced it with that. And then I write the rest. Okay, so now I can actually solve it because before you couldn't solve it because you had two variables. So solving for x, I would move the x over to the other side, so I subtract x, that would give me x equals a negative 5, and there's nothing in front of this x for me to have to divide, so I've got my first answer. Okay, now we need to solve for the y. Okay, and again, it doesn't matter which one of the equations, because it has to work in both. Okay, doesn't matter which one you plug it into. Again, I just think it's probably easier and smarter to plug it into the one that's shorter. It's less operations for you to have to do. So again, this reads x is a negative 5, so if x is a negative 5, then that means I can replace this x in this one, or the other one, it doesn't matter, with a negative 5. But what is happening with 2 and x the way it's written right now? Multiply. So really, this looks like this. Okay, so y would be what? Negative 10. Okay, so when you're doing these, you can check to see if your answers are right. So you have an x value and a y value. You could plug it into either one of the equations or both of them. Okay, it has to work in both of them because you're using the other equation to solve for the other. Okay, so if x is a negative 5 and I decide to plug it into this equation, okay, I'm going to replace my y with a negative 10. Okay, and then I write my equals. And then we just said the x was a negative 5, and then I write the rest of the equation. So what you're checking is, does the left side equal the right side? Is it true? Yeah. So we know we did it right, okay? Or you could plug it into the other one, okay? So if I put the x in here, we already know that's going to be a negative 10, and then on this side would be a negative 10, so it balances out. So it has to be able to work in both, otherwise you did something wrong. Okay, so trying another one. This is still substitution. 71. Okay, so we need to have one of the equations with a variable by itself. So they have one set up for us. Okay, so remember this says y is this. Not part of it, it's all of that. Okay, so where the y is at in the other equation, we're going to replace the y, take the y out of there, and put this in this place. So again, when the 2 and the y are next to each other, it means multiplication. Okay, so when we write it, we've got to write it as multiplication. Just replacing the y, because it was 2 times y. Well, I've got to now replace the y with that, so that means I need to distribute. Okay, so distributing that first. So I have x plus 4x plus 2 equals negative 8. Then what? Combine my terms. So 4x and a 1x would give me 5x. Okay, then my next step would be to subtract the 2, and my last step would be divide by 5. So subtract the 2, and then divide by 5. So my x would be a negative 2. Okay, then you just go back to, remember it has to work in both, so it doesn't matter which one you pick to plug it back into. So I'm going to replace the x in one of the equations with a negative 2. So you can plug it into this one or this one. I think it's, personally, I would choose that second one. Okay, so 2, if I'm replacing that x, it would be y equals 2 times a negative 2, right? Because they're next to each other, plus 1. So that would be y equals a negative 4 plus 1, which would be a negative 3. So a -2 and a -3. So if I plugged it back into this one to check it, the x was a -2, right? If I plugged in a -3 here and went 2 times a -3, what does that give me? 2 times a -3? -6. So does the left side equal the right side?
Yes.
Yeah, we did, right. And a lot of times, you could just probably do that in your head to check it. You don't have to write it out. I'm just showing you how you can check these if you're checking them for test reasons. Okay, we good? Okay. Next one. We're just trying a different variable this time. Okay, so now instead of a y, we have an x. Okay, so x is this, so I'm going to replace the x in the other equation with that. So now it's no longer an x, it's going to be that, and then I write the rest of my equation. So now I'm solving for y this time versus the x for the first time. Okay, so combine our like terms. So I'd have a -9 minus y equals a -14. Okay, add my 9, add my 9. So now I have a y equals a -5. But I've got what? That by negative. We're just switch the sign, right? So it'll go from a negative to a +5. Okay? And then again, just choose which one, because it has to work in both, which one it's easier for you to plug back into. Okay? I think it's this one that I put in the box around. So to solve for x, I have to replace my y with 5. So a -9 plus 5 would be my x would be what? -4. Okay, so if I were to check it with the other equation, the x is a -4. A -2 times 5 would be a -10. A -4 and a -10 give me a -14. Kind of remember this from a couple of years ago. Okay, you get to try this one. Okay, so moving away from substitution. So now we're going to go to elimination. Did I go too fast? Okay. Okay, so on elimination ones, you want to make sure that they're lined up. Like the equations, the x is lined up with the x, the y is lined up with the y. They don't have to be written exactly like that. They could be written like, so if you go back to like this one, you just want to make sure the x's, so like if you decided to write it like this, you'd want the x by itself equals. So you would leave that there, move the 4 over so it's lined up with, okay, so it doesn't have to be written x and y together on one side. Okay, just make sure they're lined up. X's with x's, y's with y's, equals, the whole thing. Okay, so our whole goal to eliminate means to get rid of something. Okay, so to get rid of it, it means the variables have to be the same. Okay, the numbers in front have to be the same, but then the signs have to be opposite of each other. Okay, so this one's kind of already set up for us to get started. Okay, so this one right here, they're lined up, they're the same number, same variable, one's a positive, one's a negative. So we've actually already eliminated the y's. Okay, so really what you're thinking about is kind of like an addition subtraction one where you're combining like terms, the signs are already set up for you. Okay, so you have a 2x and a 3x, so that would give me 5x. Okay, those guys canceled out. We just looked at them and combined the like terms. Okay, and then you've got a negative 12 and a negative 3, so that'd be a negative 15. You divide by 5, divide by 5, so my x would be a negative 3. Okay, and then you go back to either one of them. Again, you just pick which one because it has to work in both. I always look to say, okay, well, where's my x smaller, just because then I have a smaller number to work with. Okay, so I'm going to replace that x with a negative 3. So it's really 2 times a negative 3 minus 2y equals a negative 12. Okay, because I chose to plug it into that one. So it's a negative 6. So I would add the 6, add the 6. So negative 2y equals a negative 6. So my y would be positive 3. Okay, so I'm like, I don't know, this is my first one, I don't know if I did it right. Well, I plugged it into that one, so I'm going to check it with this one. So 3 times x, well, 3 times a negative 3 would be a negative 9, right? And then 2 times my y, and my y is 3. So 2 times 3 would be 6. Did this side equal that side? Yeah, so we did it right. Okay, so my two answers are negative 3 and 3. Something I didn't point out. When you go to do this on the exercise, make sure we know which one's which. Like which one is your x, which one is your y. On the exercise, they'll put your answers in coordinates like that. So your x, and you could do that too if you want to. So x is a negative 3, and then your y was 3. Okay, and they'll probably have both of them flipped, so make sure you know which one's which when you go to write them. Okay, let's try it again. Not as easy as this one. Ooh, fractions, shut down. Okay, ready? Okay, we don't like working with fractions, correct? Okay, so we want to get rid of the fractions. So if you had IMAC, because I know I didn't have you guys in algebra, it's been a couple years.
If you had IMAC, he taught you how to get rid of fractions so you don't have to work with them, okay? Because it's just easier to work with whole numbers. So we can rewrite the whole equation so it's not having fractions. You can work with fractions, okay, to solve for things, but it's just a lot easier when you don't. So in order to get rid of the common denominator, okay, we got to multiply the whole thing by whatever the common denominator is. Now, you don't want to have to do both of the equations at the same time. Just do them separate, okay? Because otherwise you get too big of numbers if you have to worry about the top equation and bottom equation, okay? So I'm just going to do this top one first. So my common denominator is what? 3. Okay, so we put parentheses around the whole thing because you can't rewrite just a part of an equation. It has to be the whole equation, okay? So we're going to multiply this whole, I'm going to put it on this side, multiply the whole thing by 3, because that is our common denominator. So when I do that, it gets rid of this, right? Because 3 can go into 3 how many times? Once. Okay, so I'm really just distributing 1 to whatever's left. Another way, we just say, well, we just cross cancel those, right? Okay, because that would be the same as 1 times that. Okay, so we have a -1. Okay, well, if I distribute that one to this one, it's going to do the same thing. So it's just going to change it to y, because, okay, distribute it to this one, it's just going to be x. Okay, so this equation and this equation are actually the same equation. Okay, we just increased it, each one of them by 3 is what we did. Okay, now we want to do it again. So that's a lot for you to look at that one. Okay, what is my common denominator for this one? 4, okay? Because it has to be able to go into it. Okay, so if you put a 2 out here, 4 can't go into it. Okay, so the 4s would cross cancel just like we did with the 3s. So that would leave it as a -7. Okay, 2 goes into 4 how many times? Twice. So it's not 4 that you're distributing, it's really 2 that you're distributing. Okay, so 2 times what is there? So a -2y. Okay, and then what's my last one? X, right? Because of course we'll just cross cancel. So 1 times x is going to be x. Okay, good? Okay, so we're lined up just like the last one. The x's with the x's, the y's with the y's, and then the equals with the equals. Okay, but we don't have the same numbers. Okay, so we have to solve for both the x and the y. So which one do you want to solve for first? The x or the y? X. Okay, so we need the x to be the same, which it is, but it's not what? Opposite. One needs to be a positive, one needs to be a negative. So to do that, we have to change all of it, not just part of it. Okay, so you just pick which one you want to make negative. So I'm going to make this bottom one the -1 just because we have it lined up and it's just, you're used to having a negative on the bottom. So I need to distribute this by a -1 to switch it, right? Which basically just switches this to a negative, right? This one to a positive, and this one to a positive. And all we did was we distributed a -1 through to what was originally there, okay? So it switched the signs of it. You good? Okay, because remember, you can't change just one thing, you have to change the whole equation. Okay, so that's been eliminated, okay? So I have a positive y and a positive 2y, so that's going to be 3y, okay, equals what? 6, okay? Divide by 3, so my y would be 2. Okay, I don't want to have to plug it back into the fraction ones, so go to the ones that you rewrote, because remember they're equivalent, we just rewrote it. So to me, this top one looks more easier. It doesn't matter because that's worked for both. So I'm going to replace the y with a 2. Okay, so I'd have x plus 2 equals a -1. So to solve for x, I would subtract my 2, subtract my 2. So my x would be a -3. Okay, I'm really insecure about this one because I just did fractions. I don't know if I did it right. So I plugged it into this one, so I'm going to try this one now. Okay, so if the x is a -3, and then I had a negative, I'm going back to the original, so I had a -2 times y, so a -2 times 2 would make it a -4. Okay, so does that equal what my original one was? Yeah, so it works. You could have gone with the one that switched to the opposite. It doesn't matter. It's still the same equation. Okay. Yes?
So when you're like like canceling down, the middle number doesn't have to be opposite signs.
No, one of them has to be opposite signs to get rid of them. So this one, we had the same number because it was
Get rid of both of them.
one of them to solve for the other one, but both of them don't have to be.
All right.
Okay, so let's try another one before you try one on your own. Okay, are they lined up? No. So we need to get them lined up. And again, you can leave them in the format where they, 1 equals something, or you can move them so x and y are together, x and y. It doesn't matter. Just remember when you're moving things to the other side of the equal sign, they're going to switch signs. Okay? So I'm going to line them up just like our first one. Okay, so I'm going to leave this one. So as long as they're both lined up the same, then that's fine. I want to move this one over the other side, so it just switches from a positive to a negative. Okay, and I'm going to leave this one on the right side. Okay, so all I did is rewrite it so I can get them both the same. Okay, so my second one, 4y, is on the left side of the equal sign, so I'm just going to line it up. Okay, it's a positive 4y. Right, I didn't have to move it to the other side. Okay, but I need to move this over so it can be lined up with this one. So it'll change it from a positive to a negative. And then I don't have to switch that one because it's on the right side of the... So now everything's lined up. Okay. What do you want to get rid of, the x or the y? X, because it doesn't matter, it's all for both. Okay, so she decided to get rid of the x. So we have a positive and we have a negative, so that's good, but they're not the same number. Okay, so we need them to be the same number. What can 4 and 5 go into? 20. So to make this one 20, I would have to multiply the whole thing by 5. Okay, to make this one 20, I'd have to multiply the whole thing by 4. Okay, so we're going to rewrite our equations. So we distribute, rewrite them, and then distribute. So I'd have 20x minus 25y equals a negative 30. Okay, now distribute that one. Okay, so a negative 20, and then positive 16y equals 48. Okay, we're able to get rid of the x's, right? So the x's go away. This would give me a negative what? 9. That one gives me 18. Okay, divide by a negative 9, so y would be a negative 2. Okay, I would go, because these, you can plug it into these, but you'll have a bigger numbers to work with, so I just go back to your original. So the y, I'm going to choose this one just because it's smaller, okay? So 4 times a negative 2 equals 5x plus 12. Okay, so this would be a negative 8. Okay, so I'd move my 12 over. So now I have a negative 20 equals 5x. So x would be okay, so if I checked it with this one, 4 times a negative 4 would be a negative 16. Okay, and I'm trying to decide if it equals the left side equals the right side. So if I plugged in a y here, which is a negative 2, 5 times negative 2 would be a negative 10, and a minus 6, so it equals the other side, so we did it. Okay, ready? Okay, one for you to try. Similar to what we just did. So some of you might have gone a totally different route. Doesn't matter. You should have still came up with the same answer. So I know I saw somebody that just left, like, leave this one alone and just rewrote this one. So they just blocked these two things. You can do that. Okay. So make that a negative 5x and this a negative 2y. Okay. And then they're lined up. Okay. You still should get the same answer. Okay. The only caution to this is when you multiply this one by 5 and this one by 2 to get to your 10. When those go away, it's a 0 on this side. So just remember, because this is the common mistake I see over and over. I think you found that being like 21y plus 21, I think. Okay, so then you have to move that back over. So don't just go divide by 21, divide by 21, and solve for y. Okay, because that's a common mistake people do. You got to move things over to isolate it. Okay. Good? Okay, so we're crossing off 71, 72, 74, 75, 77, 78, 79, and 82. So you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 right here. Okay. We will grade it not tomorrow at the beginning of class. We will grade it in class. So we're getting close to the end of time. So start a little bit, at least half of it. Okay, and then we'll finish the other half. We'll finish it all, I guess, if you want to do homework. So tomorrow you'll work on that. We'll grade it towards the end of class. And then if you get done and have time, then there's just con exercises, no con videos. Okay, that will do this round. Okay. Okay. So at the very end of class, we'll grade the last, because I'm just reading X is this, Y is this. It'll go pretty quick. Okay, so you'll have class time to work on it, but we'll grade it tomorrow by the end of class.